Hello, let's continue our Sudoku adventure with Yagi by Tony Zampini. So we do have normal 6 by 6 Sudoku rules, meaning in each row, each column, and each 2 by 3 box, we are placing the digits 1 to 6 exactly once each. We also have these thermometers in the grid. These are these thick lines with a circle attached. The circle is the bulb of the thermometer. So if you think about a thermometer, the bulb is the coldest part. So the bulb is the lowest digit here. Now they don't have to increase in any specific way as long as they increase. So this is 2. We have to get bigger after the 2. So we can't repeat the 2. We can't do a 1. We could do 3. We could do 4. We could even do 5. Then this, let's say this was 4, this just has to be bigger than 4, or 5, or a 6. So this would be one way to do it. This could be a way to do it. This could be a way to do it. We could do that. We could even do 3, 4, 5, as long as they increase. All right, so that's thermos. We also have this main diagonal on the grid, the what we usually call the positive diagonal, because if you were looking at a graph, that would have a positive slope. But it's kind of weird because we number this way, right? This is 1, 2, 3, 4 vertically. So you would think it would be the negative diagonal. But anyway. This diagonal, the one that's marked, also has the digits 1, 2, 6 exactly once each. It works just like a row, column, or box. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so the given 1 is making me think about where do 1s go, because 1s can't be on thermos except in the bulb. So let's highlight everywhere that can't be 1, right? If I make these green, this is everywhere that can't be 1 right off the bat. So we know the 1's up here somewhere, and the 1's in one of these two, and down here somewhere. But I don't know that we get much more out of that. We can also look for 6s. 6s can't be anywhere except the end of thermos. So a 6 on a thermo is only on the end of a thermo. So none of these are 6. That's really not all that interesting, is it? I mean, 6 is in one of these 3. Okay. So what else can we do here? We could pencil these thermos. We could start with this longer one. So the way to pencil this, there's a few ways to think about it. Let me talk about this way. So if you just start with the lowest digit that could go here, it's not a 1, it's a 2. And you just increase by 1, 3, 4, 5. Now we've reached the end. Now the end is 5, meaning we have 1 degree of freedom, because the tip can be as high as 6. And so each of these can be 1 higher. So this can be 6, this can be 5, this can be 4, this can be 3. So we end up penciling this way. These are the possible digits on these cells. Now, what do I do with that? I could pencil these. So this is 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6. Same thing here. Now, these two digits are not the same as each other. Interesting. So this can't be a 1. That's neat. Okay, this can't be a 1. Because imagine it was a 1. Well, this can't be a 1 now because of the diagonal. This can't be a 1 because of the thermo, and this can't be 1 because it sees a 1. Therefore, this can't be 1. And when we remove the lowest digit, that propagates upward, removing the lowest digit as we go. So that limits these. This is not a 1. Okay. Does this have a similar issue? No, because there's not stuff sitting over here. This could be the 1. Oh, interesting. I'm still thinking about where this goes. Like this digit here, let's call it green, goes in one of these two spots. So if it's a 2, this has to be a 2. Not sure that's helpful. And then this digit goes over here. I don't think that's helpful at all. Do we want to think about 5 and 6 on the diagonal? They go there. Is there a problem with like 4, 5, 6 or something? Or 4, 5, 6? Or 4, 3, 2? It's interesting. If this was a 4, we go 4, 3, 2, and this cell here then couldn't be the 2, the 3, or the 4. So I guess one thing to say is I could color these. I could make this blue and this orange, just random colors, because we know all 3 of these are different digits. It's kind of interesting, isn't it? This purple sees all three of these through the diagonal and then through the column. The green sees them all because you can't repeat digits on thermo. They have to keep increasing. So the green sees this, sees purple by diagonal in these two. And then these two see purple by column and they see the green by the thermo. So these are 4 different digits. And this sees all of them. So this has to be, say, yellow. This is our yellow digit. So we have the green is down here somewhere. Another reason green can't be 1. Interesting. So this is green with red. Let's just call that red. Interesting. What do I do with that? It feels like an important deduction. Do these do the same thing? These do the same thing. These two are also not green or purple. So purple ends up here in this column. And then, see, I don't know if these are blue, orange, or not. What am I missing here? So a problem with like 3, 4, 5, 6. Oh, think about how thermos are forced can often give you like, well, the forced version of the thermo can sometimes just break stuff on its own. So like 3, 4, 5, 6. Is that a problem? Can I do more with these colors? That's another question. Yellow, red. I don't know. Does yellow has to be 5, 6, doesn't it? No. I was thinking about. Think about how green is down here. Adding a 2, 3, 4 to the mix. I don't know. Is this one doing anything I haven't noticed yet? Maybe we can think about this digit. Oh, this digit is interesting. I'm going to color it yellow because it has to be yellow, right? Where does this digit go in this box? Well, it can't go in this column. Repeat in the column. It can't repeat on its own thermo. And it's too big. It's 5 or 6. It's too big for this bulb. So yellow is here. So that's actually 5, 6, meaning it's not the 1. So that actually places our 1. So purple is 1. So this is purple. And then that doesn't affect our thermo at all. It's kind of the I don't know if the 5, 6 helps, but is there a problem with coloring this one or this one? Yeah, this digit here goes over here. What can it be? It's not purple, red, or green. And it's not yellow, obviously. Yellow's on its thermo. So if it's not red, green, purple, yellow, it's blue or orange. Oh, well, if this has to be blue or orange, it has to be the blue. The blue is the only one that can accommodate that. So blue is 3, green is 2, and then this is a blue 2. Sorry, blue 3. That makes this 4, 5, 6. So yellow is 6. That's not 2, 3, meaning that's not 3, 4. Okay. So blue is not down here. So it's here or here. Well, this is, let's see, this is not green. This is our green too. I probably don't need my colors anymore. I don't think they're helpful, but they did their job. Very nice. Be easier to do Sudoku without worrying about the colors. This is 4, 5. That's a 4, 5 pair. This is 1, 2. So this is a 6. That's 5. That's 4. Okay, that's 4. So this is 5, 6 just for the diagonal. That makes that 5, that's 6. That's 5, that's 4. Okay, we're doing well. This is a 2, 5. So 5 tells us that's 2, that's 5. Up here, I need a 1, 4 pair. Down here, I need a 3, 5, 6. Well, the 5 can only go here. 1, 3, 6. This can't be 3 or 6. So this is our 1, 2, and 1. This is a 3, 6, not a 6. So that's 3. That's, oops. That's 3, that's 6, that's 3. Here we finish the row with 2, finish the row with 4. That's 1 and 4, that's 1. I need 2, 3, 6. So this is the 3, this is the 6, that's the 2. Get a 3 in the corner right at the end. Neat puzzle, Tony. I enjoyed that. Yeah, I think coloring really helped. Just looking at the geometry of some of these and comparing them. I don't know if I solved this in the intended way, but I certainly enjoyed the way that I did it. So, cool. We always make puzzles our own, right? Well, let me know how you did. If you enjoyed it, why not leave a like, subscribe, and a kind comment below.